Today we want to look at indices. So the question is, what is an index? The word indices represents plural form. Then index, an index, this is for singular. Okay, so in these indices, we are going to look at positive, 0, and negative indices. Okay, so we're going to look at positive, 0, and negative indices. So what do we mean when we say positive indices? When a number 2 to the power 3, the 2 is called the base, then the 3 is called the power, or it can be called an exponent. So this base is the one we are going to multiply by the number of times indicated on the power. So 2 to the power 3 means 2 is being multiplied 3 times. So if we were to expand this, it will be 2 times 2 times 2. We've expanded it. Or if we don't want to write it in expansion form, we can just write it as 2 to the power 3, meaning 2 has been multiplied 3 times. It is not 2 times 3, which is 6. This is 2 to the power 3, meaning we multiply 2 3 times. If we were to multiply here, if we were to evaluate, we're going to get 8 as the answer. But if we were to just multiply 2 times 3, this is 6. So 2 to the power 3 implies 2 multiplied 3 times. So this is a positive index. Okay, we can also look at 2 to the power 4. 2 to the power 4 also indicates to us, 2 to the power 4 also indicates to us that 2 has been multiplied 4 times. 2 has been multiplied 4 times, which is 2 times 2 times 2 times 2. Okay, then we can also have 2 multiplied to the any factor. It can be 2 times 2 times 2 n. Okay, so we can equally write this as 2 to the power n. N will represent the number of times 2 has been multiplied with. This n is the nth number, which will represent any number that 2 can be raised to. So we can have a positive power, we can have a negative power, we can also have a negative power. Okay, so we're going to continue looking at 0 indices. These are positive indices. Then we're going to look at 0 indices. What happens to a number which has been raised to the power 0? Okay, so we can also look at 0 indices. 0 indices are those indices that have been raised to the power 0. For example, if we have 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. Then we can also have negatives coming in, 2 to the power negative 1, 2 to the power negative 2, and so on. The next will be 2 to the power negative n. Okay, so if you check what is happening here, 2 to the power 4 implies that 2 has been multiplied 4 times. If we were to multiply 2 4 times, we're going to get 16. Next, 2 has been multiplied 3 times. When we multiply 2 3 times, we get 8. 2 to the power 4 will give us 4. 2 to the power 1 will give us 2. And 2 to the power 0 will give us 1. So any number raised to the power 0 is 1. Any number raised to the power 0 is equal to 1. So 2 to the power 0 will give us 1. Then there are indices that can be given with a negative power. There are indices that can be given with a negative power. We can convert them to positive indices or vice versa. Okay, so if we have 2 to the power negative 2, if we have 2 to the power negative 2, this can be expressed as 1 over 2 to the power 2, which will give us, when we evaluate it, it will give us 1 over 4. So those indices that have been written with a negative power, we can change them to be positive indices. Or if the indices have been written with a positive power, we can also change them to be negative indices to suit what we are finding. Okay, so if we have 2 to the power negative n, it will be 1 over 2 to the power n. Then we solve. So this will be 2 to the power n, and since we don't know the value of n, we can't replace. N can mean any integer. N can mean n negative integer. In this case, we're looking at negative indices. Okay, so we've said here that any number raised to the power 0 is equal to 1. Whether it is 100, it is 1000, as long as it is raised to the power 0, the answer that it will give us, it will be 1. Then on the negative indices, how can we convert them? We have negative indices. How can we expand these negative indices? How can we expand them? If we have, as we said, 2 to the power 5, 2 to the power negative 5 will be equal to 1 over 2 to the power 5. Then we can expand over 2 times 2 times 2 times 2 times 2, like that. That will be in expansion form. Okay, so if we are given to expand any number which may be in this form, negative 2 to the power negative 3, this one will be 1 over negative 2. The only thing that will change will be the power, which will become a positive. Okay, so to the power 3 now. So this will be 1 over negative 2 times negative 2 times negative 2 in expanded form. Then if we are asked to evaluate, we can evaluate this by multiplying negative times negative, positive. Positive times negative, it will be negative. This will be 1 over, let's multiply the signs, negative times negative, it is positive. Positive times negative, it will be negative. Then 2 times 2, 4. 4 times 2, it will give us 8. So that's how we can go on if we are asked to evaluate. Okay, so these are positive, 0 indices and negative indices. I'll write a few more examples on how we can deal with each of these 3 types of indices that we've talked about. Okay, so we can look at some more examples. We need to expand each of the following. A, 2 to the power 6, B, half to the power 3, C, 0.3 to the power 2, then D, x to the power 3, and E, negative 2 to the power 3. Okay, so to expand, we want to make these values which have been given in expanded form. Okay, so to expand 2 to the power 6, we'll just write this 2 is the base, 6 is the exponent or the power or the index, meaning it is telling us how many times we're going to multiply these 2. So it will be 2 times 2 times 2 times 2 times 2 times 2. We've expanded. Then half to the power 3, this means 1 over 2 times 1 over 2 times 1 over 2, like that. Then 0.3 to the power 2, it is telling us how many times we're going to multiply 0.3. So it will be 0.3 times 0.3, like that. Then x to the power 3 is telling us how many times x has been multiplied. So it will be x times x times x, like that. Last but not the least, we have negative 2 to the power 3. it is telling us how many times this negative 2 has been multiplied. So it will be negative 2 times negative 2 times negative 2. This is the expanded notation. The question just required us to expand. Okay, then we can go on to evaluate the same questions that we've been asked. We can go on to evaluate the same questions that we've been given in expanded notation. So we can say evaluate. Evaluate each of the following. How do we evaluate each of the following? The same values that have been given here, we can say A, 2 to the power 6, B, half to the power 3, C, we can say 0.3 to the power 2. How is it going to be? Then D, we're going to have x to the power 3. Then E, we're going to have negative 2 to the power 3. So in expanded form, 2 to the power 6, we multiply it 6 times. So it will be 2 times 2 times 2 times 2 times 2 times 2. Then we multiply. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. And 32 times 2 will give us 64. So that is the answer. Then half times half times half. Okay, when multiplying fractions, we multiply numerator by numerator, denominator by denominator. So this will be 1 times 1, it will be 1 times 1, it will be 1 over 2 times 2, it will be 4. 4 times 2, it will be 8. Okay, then we have 0.3 squared. So it will be 0.3 times 0.3, which will give us 0.09. Okay, then x to the power 3 means x times x times x, which will be x to the power 3, because we can't write any value, it is just x. So it will just be x to the power 3, meaning x has been multiplied 3 times. Then this, it will be negative 2 times, remember the negative is the base, it is not the power. Okay, so it will be negative 2 times negative 2 times negative 2, which will give us negative 8. Okay, if we had something of this kind, maybe we say f negative 2 to the power negative 3. This will be 1 over negative 2 times negative 2 times negative 2, which will eventually give us 1 over negative 8. Like that. Okay, so watch out for the class activity. Watch out for the class activity in the notes that will be provided below. Thank you so much.